Good afternoon, guys.
Afternoon, sir.
Sorry for the late start. I was having a serious problem with my network. It wasn't going through. I think it's sorted now.
Okay, sir.
Okay. Um, to avoid, you see, the last time we're having this feedback with noise coming from the background. So if you are not talking, then I will suggest you mute your audio. Yeah? You can unmute it anytime you want. Are we together?
Yes, sir.
Good.
Yes, sir.
All right. We are going to start right away. Welcome to today's session. You remember the last time we met, we were discussing this particular question next, where we were looking at how to find the values of A, B, and C. And I believe from the discussions, everyone was okay, including the simultaneous equations that we did, right?
Yes, sir.
Atipe, were you okay that day?
Yes.
We also did this particular question, exercise 8.5, question 1, right?
Yes, sir.
Good. Let's take the question 2. Let's start today with the question 2, and then we will see how that should be answered. What line is this OM?
Radius.
Hotel, what line is this OM?
Radius.
Now, what line is this ON?
Segment.
A segment is a space. Ne?
Uh-huh.
Segment is actually the space that is covered by an arc and then a chord. Are we together?
Okay. Yes, sir.
Like right now, we have an arc here. This arc. We have an arc here. So if we draw a chord from here, from P, point P, straight to point K, then that space this side will be the segment. Sorry.
I was going to call myself.
Oh, okay. All right. Then let's move on. So, guys, what I wanted to draw your attention to is that this is not a radius because it goes outside this circle. Ne? But let's look at this NP. What line is this?
It's a tangent.
It's a tangent. LMN is what?
Tangent.
It's also a tangent. You see that?
Yes,
Yes,
sir.
sir.
So it means we have 3 different tangents here. There's a tangent LK here. We also have tangent LMN. And then we have tangent NP. And guys, you still remember what we said that day, that whenever 2 tangents from the same point outside a circle are drawn, they do something. So will you tell me what is going to happen here? Matipe, what will happen here?
Right angle, sir. 90.
There will be a right angle, ne? The reason is what? Skitlani, what is the reason here? Why is it that it will be a right angle?
Radius is perpendicular to tangent.
Radius is perpendicular to tangent. I believe you all see the radius, ne?
Yes, sir.
Good. I think we can say the same thing here, ne?
Yes.
What is the radius here?
OM.
Radius of OM.
Radius OM. In that case, I want to believe that you agree with me if I say we have a right angle triangle here. O.
Yes, sir.
Where else do you see a right angle triangle?
KLO.
K.
LO.
LO. Where is the right angle?
It is when K and the line from
The line from? Are you there?
center.
You're also breaking now. Yes, anyone to help? It seems a line is breaking. How hello? Matipe.
Sir,
Mm-hmm.
radius
Okay.
KO.
Radius what?
KO is
KO,
perpendicular
ne?
to
Okay. Mm-hmm.
Yes.
is
It's perpendicular
perpendicular
to
to LK.
LK, which is the tangent, I believe, ne?
Okay.
Perfect. So this is a right angle triangle. We said this is a right angle triangle, OMN. Now we are saying KLO. It's also a right angle triangle. Where else do you see right angle triangles? It seems we have how many right angle triangles in this diagram?
4.
Or
4.
Yes, sir.
Are you sure?
Yes, sir.
This is 1.
Yes, sir.
Is this is a right angle, ne? Right angle triangle.
yes, sir.
And
Yes,
this
sir.
plus this, and then plus KLO. Fine.
Yes, sir.
Guys, whenever you see a right angle triangle, what comes into your mind? Which theorem comes into your mind?
Pythagoras.
Pythagoras theorem. Fine. Now, this is also a radius, ne? Which is 2 centimeters.
Yes, sir.
Where else can we say it's also 2 centimeters?
OM.
O,
OM.
ON,
And OP.
2 centimeters, yes. And then OP, ne?
Yes, sir.
What about ON?
It's not a radius.
It's not a radius. Thank you. Okay, let's also go to this LK. LK is 6 centimeters. Can we take this LK somewhere?
Yes, sir.
Where?
To LM.
L,
M.
LM or LN?
LM.
Oh, okay. But do you see this statement down here?
Yes, sir.
Then you guys must find the length of MN and tell me the answer. MN.
1.5 centimeter.
1.5 centimeters. Perfect. So, guys, this is the situation. We want to find the length of ON, which is letter E, small letter E. Now we have seen that this is 1.5 centimeters.
Yes,
This
sir.
is what?
2 centimeters.
And here we have what?
A right angle.
So we use our theorem of Pythagoras and we solve it, ne?
Yes, sir.
That is how come we get E. So I'm going to show you the answer to the question, and you realize that they followed exactly what we talked about. Ne? When you see the diagram, you don't have to look at the entire thing, else you'll get confused. Just look at it in pieces, bring the theorems which are related to that particular part only, and then you will see you'll get something from it. Ne?
Okay.
Great. So let's look at the solution to this one. And you see it begins with LK, 6 centimeters. LK is 6. And then LM becomes 6. That is exactly what you guys told me. Ne? Because there are 2 tangents from the same point. Fine. Meaning we will get 1.5, which is exactly what you guys told me. And the radius here is 2.
Yes.
So we have that 2 here. You can clearly see the OM is 2. Then theorem of Pythagoras comes in. The theorem of Pythagoras, what does it say, guys?
Opposite plus adjacent, both squared, is equal to hypotenuse squared.
Since you have put the two together, remember it is the longest side squared, which is the hypotenuse, ne?
Yes, sir.
In this case, that is E, should be equal to the sum of the squares of the other two sides, and these are the other two sides. So that's exactly what has been used here, and then you make E the subject. I mean, you get rid of the square, and you have your 2,5 centimeters. Any questions with the way this particular work was done?
Nafi.
You are fine, eh?
Yes, sir.
Anyone? Mutel,
Sir?
are you fine?
Yes, sir.
Very good. Meaning you can use the same concept to find the length of NP. What is the length of NP? This line.
1,5.
Why 1,5?
Two tangents from the same point outside the circle are equal.
That is perfect. That is perfect. So I am very sure that you guys will be getting a lot of marks from the work which is coming very soon. All right, then let's move on to the next question, which is question 3. We have 3 centimeters, and then we have letter F here. Mutel, this question is yours. What should be the size, the value of letter F?
3 centimeters.
3 centimeters. Matipe, what is the reason behind that?
2 tangents from the same point outside the segment.
Okay, Skitlani, he mentioned the same point. Which is the same point here?
Sir?
Which point are we calling the same point?
S.
Point S. I am sure we are together in this, ne?
Yes, sir.
Very good. We move on to the next. Let me go to this work. Going to this work. Let's look at it. It's not so clear from the diagram they put out there, but let me clarify it for you. This is H. It's not D. It's H plus 20 degrees.
Yes, sir.
And this 4H minus 70 is for this angle R. So that is the diagram
Yes.
you are seeing there. A circle here. Forgive my drawing. I was trying to put it on the circumference, but it just went out. So let's assume that this point is on the circumference, okay?
Okay.
Good. Then somebody says, I am going to produce a tangent. Let's say the person draws this line and calls it a tangent, ne? If this is a tangent, and we name this point A, point B, and point C. As this is my center O. Okay? Let's talk about a few things here. This angle you see outside here is an angle between what and what?
It's a chord and a tangent.
It's an angle between a chord and a tangent, ne?
Yes, sir.
Which chord is that?
AB.
Chord AB.
Chord AB, and the tangent is the green one.
Yes, sir.
And we say that the angle between tangent and chord must be equal to, from the revision we did, ne? The angle between tangent and chord should be equal to what?
1H.
No. It should be equal to the angle in the...
Oh, C. It
Yes,
should be equal to C.
yes, it should be equal to C. But I want you to complete it with the statement, ne? The angle between tangent and chord should be equal to the angle in the alternate segment.
Segment.
Mateo, did you hear me?
No, sir.
You got me, ne?
I know.
No, what I mean is this. This is the angle between the tangent and chord, right? Now, because of this chord, we have a segment this side. There is a segment here. If you look here, you see this side?
Yes, sir.
This is a segment. That space is a segment. And then, because that is a segment, this is also a segment, this side, the whole of this side. Above that line, above that chord, yeah?
Yes, sir.
It's also a segment. So we have one segment here. That is where that first angle was formed. And then on top of this line, we have a second segment, which is the whole of this space. The whole of this space, because we are considering only this chord, okay? So if we say we have one segment, then the other segment is called alternate segment. Are you together?
Yes, sir.
Good. And if you look at point A is the one which goes to C. Then you look at point B. Now I'm talking of line AB, called AB. Then B also goes to C. So we say that it is line AB that has subtended angle C. Are we on the same page?
Yes, sir.
Good. That is where we say tan chord, because the angle between this tangent and this chord is now going to be equal to the angle that is produced by this very chord, but in the alternate segment, the other segment, which is angle C. Okay? Are you okay, guys?
Yes, sir.
So if this is 50 degrees, then this must be what?
20 degrees.
50 degrees. That must be 50 degrees. Fine. Let's go back to this diagram and then compare some few things. You see that here we have H plus 20 degrees. H plus 20 degrees. That is the angle between the tangent and chord. You get it, man?
Yes, sir.
My question is this. Which chord subtended this angle R?
SQ.
SQ. You see that? So
Yes,
since
sir.
SQ is the one that subtended angle R, then we are going to treat it the same way as this one. Which means some angles here must be equal. Which angles are that?
Angle Q and angle R.
Angle Q. Remember angle Q, we have three different angles. This is 1, this is 2, this is 3. Which of them are you talking about?
Q1.
I'm trying to see Q1 and I don't see Q1. So
Okay, sir, the one that is H plus 20 degrees.
perfect. It means H plus 20 degrees that I've written here should be equal to what?
4H minus 70 degrees.
4H minus 70 degrees. And we need to provide a reason. We need to provide a reason, guys. Let me.
Alternating angles of the same segment.
Are you sure, guys? Are you sure?
Yes, sir.
This is the H plus 20. This angle here is the 4H minus 70. Very similar to that weight. So what is the reason? Why are they equal? Why is this equal to this?
And chord.
Tan chord. Thank you. The reason is,
Tan chord.
guys, we are running out of time. And chords. So if the reason is tan chord, then we should be able to solve for H. You see?
Yes, sir.
So what should I do in this case?
Transpose.
Transpose what?
H to the 4H and -72, the 20.
All right. So I am going to transpose H to this side. So H will come here. Ne?
Yes, sir.
When H goes there, is it going to be positive or negative?
Negative.
So I have my 4H here, and you said I should bring H here. It should be negative H. Ne?
Negative H. Yes,
Then I am
sir.
going to transpose. I'm going to transpose. Which one?
-70.
The negative 70 will also come this side. Will it be positive or negative?
Negative. Positive, I mean.
Positive, ne? Then we have to remember that it is coming to meet this 20. So it will be 20 plus 70. And 20 plus 70 is what?
90.
And 4H minus H?
3.
3 what?
3H.
So 3H equals 90 degrees.
Yes.
H will be what?
30 degrees.
30 degrees. So that is what the calculations should have looked like. That's how it should have looked like. Ne? But the
Yes,
most
sir.
important thing is your reason. You can't go and use any other reason apart from tan chord, because this is talking about tangent and the chord. Any questions on this? Any questions on this?
All fine.
You are fine.
Sir, if an angle is between a chord and a tangent, then we'll have to use the reason of tan chord. But if it's on the chord, then we'll have to use the reason of alternating angles on the same segment.
Let me clarify your point here. Let's look at this. You see, I have a new circle here.
Yes, sir.
Let me call this O. Let me produce a chord here. And then I am going to draw a tangent. Let's say I get a tangent here. Oh. Proving difficult to get a tangent. Let's say I have a tangent here. Ne? It is
Yes,
this
sir.
angle that we are calling tangent, the angle between tangent and chord, this angle.
Okay, sir.
But what does it do? It will only be equal to the angle. You see, it is in this segment.
Yes, sir.
It will only be equal to angle in the other segment, the alternate segment, only if this chord, let me call it AB, only if this chord AB goes ahead to subtend an angle in on the circumference.
Okay, sir.
Do you get me?
Yes, sir.
If chord AB goes to this side and subtends this angle, then you can say this new angle must be equal to the one which was down here. But if chord AB just comes to this side and forms an angle, you cannot say this must be equal to this. No, it doesn't work like that. It is only when the chord subtends an angle on the circumference only, then this and this will be equal. Okay?
Yes, sir.
Any other question on this? You are fine.
Yes, sir.
Good. I'm picking a new situation and then you help me to find a solution to it. Yeah? Let's look at this new situation. Imagine I draw a semicircle. Ne? I talked about semicircle the last time. Oh, this semicircle doesn't look like one, but just forgive me because we are running out of time. Eh? Semicircle,
Yes,
let's say this is still center O. Then we draw an angle to the circumference. Form an angle at the circumference. What will be the size of this angle?
90 degrees.
90 degrees. This must be 90 degrees. But tell me, what shape is this? Let me call this PQR. What shape is PQR?
A triangle.
What triangle is that?
A right angle triangle.
Fine. So, if somebody draws this, a right angle triangle, né? Will the person be right to say that anyone can draw a circumference, a semicircle, to pass here and go there, even if there is no semicircle?
Yes, sir.
Motivate your answer. Why do you say that?
Sir?
Why do you agree?
Because it will form a semicircle, and semicircles have angles that are equal to 90 degrees.
Matipe, what's your view?
Sir?
What is your view? Why do you agree or not agree that if we have a right angle triangle here, we can or we cannot draw a semicircle around it? The first thing is, do you agree that we can draw a semicircle around any right angle triangle?
Yes.
Then explain. Oh, you can.
Because the right angle is just like it has a diameter.
They have a diameter. I like the where you are coming from. It has a diameter.
So you can draw up a half semicircles.
Very good. So guys, it means that if a semicircle can have a right angle triangle in it all the time, then if there is no semicircle, we should still be able to see that the fact that it's a right angle triangle, then a semicircle can always be seen.
Yes,
even if it doesn't show, right? Then I am telling you from what we have discussed so far that every right angle triangle we formed will not only have a semicircle around it, but will always have a circle which touches all the 3 points. Let's say A, B, C. We'll always have a circle that touches all the 3 points at the same time. Anytime you see a right angle triangle, whatever right angle triangle. Okay. Clear? Then the hypotenuse of a right angle triangle will always become the diameter of a circle. Am I making sense?
Yes, sir.
This is the hypotenuse. So whenever you see a right angle triangle, that hypotenuse, if you divide it by 2, that will take you to the center. I'm going to leave it here because we've run out of time, and then just think about it. If you have any questions on these things that I've said, just post it in the group, and then we'll take it from there. We will keep on discussing to see if you need another session before you write a test, or if this is okay. Yeah?
We are